Hello viewers, you are welcome back to my YouTube channel. I hope you are doing great. Kindly subscribe to the channel and share it to others. Okay, so today we are going to consider Boyles Law under chemistry. Boyles Law. What is Boyles Law saying? Okay, so we have Boyles Law. Okay, Boyle actually is the name of a scientist. Okay, so he proposed a law, hence Boyles Law. So Boyles Law is saying that for a fixed mass of a gas at constant temperature, the volume of the gas is inversely proportional to the pressure of the gas. So he's saying that the volume of a gas is inversely proportional to the pressure of the gas at constant temperature. Please, the temperature has to be constant. So when you say temperature is constant, then that means the process is isothermal process. So constant temperature simply means the process is what? Isothermal. Thermal process. You know that iso means the same, and thermal has to do with heat, temperature. Hence, isothermal process means what? Constant temperature. So someone can also define Boyles Law this way: for a fixed mass of a gas at isothermal process, instead of the person saying at constant temperature, you can decide to say at isothermal process, the volume of the gas is inversely related or proportional to the pressure of the gas. Are you okay? So let us proceed. Now there's a topic in general mathematics or core maths known as variation. And clearly, this is the second type of variation known as inverse variation. You can see the volume here is inversely related to pressure. So this is what? Inverse variation. So let's see the application. So guys, this one, I want to tell you this. Whatever you learn from the other courses, they are applicable somewhere. So don't just learn them and throw them away. You see, mathematics has come to chemistry. You get it that way. So if you are okay, you'll be fine. Okay. So let's see how they are interrelated this way. Okay. When we say quantity A varies linearly with quantity B, so let's say A is directly proportional to B. How is the graph like? How does it look like? You understand? And if another quantity varies inversely with another quantity, how does it look like? You get it that way? Yeah. So let's see something here. So here we are going to plot. We are using Boyles Law to plot the volume of a gas against this pressure. So clearly we have it this way. Have it this way. Then this is V. My V is the volume. And this is my pressure. Because they are inversely proportional, it will take this form, this way, move this way, or can do it this way. You can decide to bring this first, the P here and the V here, and it takes the same format. Do you understand it that way? Now, someone will be wondering, why did I neglect the one over here and I decided to take P? Why? You can decide to include the one. You can plot V against this, but it will take a different format. So if your variation is very strong, you understand why it's assuming this shape. Why is it assuming this curve? This is because we are saying volume of a gas is inversely proportional to the pressure. We didn't say the volume of a gas is inversely proportional to the inverse of pressure. We are only saying pressure. And you know that in the inverse sign takes this form here, then 1 over P, to show that they are inversely related. That is why I didn't bring the 1 over here. But well, if I want to include the 1, let's see how it goes. So it also takes this format. We are saying V is that inversely proportional to 1 over P. Again, let's consider direct variation. Now here, I can also make this statement, and it is very correct. I can say the volume of a gas is directly proportional to 1 over P, which is correct. You can see it's directly proportional to what? 1 over P. But it is wrong to say the volume of a gas is directly proportional. It's directly proportional to pressure, to P. So if I say the volume of a gas is directly proportional to P, to take this form, you understand it that way. But listen to this statement. The volume of the gas is directly proportional to 1 over P. It's also written this way. And this is the same, you can also say it in a different way, but it means the same. The volume of a gas is inversely proportional to what? To the pressure. So they are the same. So either the volume is directly proportional to 1 over the pressure, or the volume of a gas is inversely proportional to pressure, and you'll be fine. So let's close the same graph. So we have 2 graphs here, and it means the same. So you can do it this way. Nicely, I have my V here. So I want to plot this V against this. So you know that V is directly related to this. Because it's directly related, it will take a straight line graph because it is directly proportional. So it will take this format this way. So you come and write 1 over P. You see the difference? So this and that, they are all the same. So please take note. That is V against P. They are inversely related. Hence it takes this format. The same here. But when I bring this, the 1 over P, remember it is directly related. So it takes this format. Quantitatively, let's see how the Boyles Law, like what does it imply quantitatively? I'm saying that V is inversely related to pressure. Very good. Again, variation will tell you that when you have something of this nature, you cannot continue. You can only continue by introducing what? An equal to sign and a constant. The constant can assume any letter. So where the constant is called the constant of variation or the constant of what? Of proportion. Are you okay? So this will be V, then I'll replace this with an equal to sign here, then I'll bring what? A constant. So I have my constant K, and my constant will multiply this expression 1 over what? Over P. So V equals my K by 1 will give me what? My K over what? Over P. If I make my constant the subject, this will become K is equal to what? VP, or K is equal to PV. You can express them this way because multiplication is what? Is commutative. Are you okay? So now if I have it this way, what does the constant represent? Now what does it mean? Now what does it mean? It means something. So whenever you see something of this nature, if I'm saying P is equal to K is equal to PV, this is the same as me saying my PV is equal to K is a constant, it's equal to my constant. Are you okay? So now, if that is the case, that means I can equate this PV to the others. It doesn't change. So if I have my PV here, PV, it should be equal to what? PV again. So P what? V. Because we are saying it's what? It's constant, it doesn't change. But here, we want to consider a situation whereby you have, let's say, a container of volume V1 and pressure P1. So I have my P1, my pressure P1 in this container, and I have the volume of that container to, let's say it's also P1. And I take another container this way. You know that the volume and the pressure will be different. Are you okay? So I have here, let's say my pressure here will be pressure 2, and my volume here will be volume 2. So I have P2 and what? And V2. So clearly, this is what we call a Boyles law. P1 V1 equals P2 V2. I don't expect you to chew this formula. Are you okay? Now let's come to the quantitative aspect of Boyles law. So V is directly proportional to 1 over T. This means if volume increases, what will happen to pressure? Pressure will decrease. Or when pressure increases, volume to what? Will decrease. Do you understand it that way? So quantitatively, when I double the volume of the pressure, if here is 2, if I double the volume of the gas to be 2, then that means the pressure here will be half. It's the opposite. So the opposite of 2 is half. Do you understand? The opposite of 3 is what? Is 1 over 3. That means inverse of 3. So if I double, so quantitatively, if I double the volume of a gas of say 2, the pressure will be half. Do you understand that way? So please, this is the end of Boyles law. Stay blessed. Subscribe to my channel and share it to others. Bye.